Hello my dear students, welcome to another class of IGCSE Mathematics 0580. We're still in this topic 4, which is sequences. We're finishing up sequences in this video. We have 6 classes. I'm sure that if you have any question about sequences, you could watch these 6 videos and you'll find the answer within. Now we are talking about assorted sequences. What I mean by this here, we have talked about arithmetic, geometric, quadratic, and cubic. And sometimes we may have sequences which are neither one of these. I just called them assorted sequences. Let's see some of these sequences. First, compound sequence or compound sequences. I've talked about this before in one of the videos. Let's just take examples here for compound sequences. When we have sequences made of sequences put together. As an example, let's say we have this sequence here. 3 times 1 plus 4, and then you have 6 times 2 plus 9, and then you have 12 times 3 plus 16, and then you have, see, this is complicated in a way, right, isn't it? 24 times 4 plus 25. This sequence, do not find the values of these here, such as finding 3 times 5 is 15. You have changed the sequence. The sequence that we have here is in this form, in this way. It is a number multiplied by the sum of 2 numbers. So don't say, I'll just add up these, 5 times 3, that's 15. You change the sequence. It is not our sequence anymore if you do that. But instead, you would deal with this as different sequences. Now, you would notice that this is made of a number in front of a bracket every time. So you have that 3, 6, 12, 24. These are the numbers in front of the brackets. So you take this as one sequence. And you take 1, the first number in each bracket, 2, 3, 4. That is the first number in each bracket out of the bracket. That's one sequence by itself. First number in bracket. That's one sequence by itself. Then the second number in brackets, which is 4, and then 9, and then 16, and then 25. So you have 3 sequences. Find the nth term of each one. Addition plus 3 plus 6. It's not arithmetic. Times 2 times 2 times 2. So this is geometric. The rule for geometric, A, the first term. I'm going to just remind you of this rule for geometric. A is the first term, R is the common ratio to the power of n minus 1. Okay, that's it. And now, add 1, add 1, add 1. This is just the natural numbers, which is always n. You don't need to do any work for this. But if you don't know, just find the difference is 1. We've learned to take the difference as coefficient of n. And then we go backward one term, which would be 0. So the answer is n, and this is arithmetic. This one here, you could just realize this as the square numbers missing 1. So this is just n plus 1 squared, and you could find it any way you like. I just use comparing to square numbers because it's obvious. And now, what would be the nth term of the sequence? It would be in the same form here. 3 times 2 to the power of n minus 1 times, in brackets, n plus, as we have a plus, plus, plus every time, so you'll have a plus here, n plus 1 squared and you leave this in this form. Do not expand and add and so on, unless they would ask you to expand this, or they ask you to simplify. You would do that, but otherwise do not simplify. Check very quick. Second term equals what? N equals 2. 3 times 2 to the power of 2 minus 1 times 2 plus 2 plus 1 squared. 2 to minus 1 is just 2, so that's 3 times 2, which is 6. Times 2 plus 3 squared, which is 9. Is it correct? 6 times 2 plus 9. Correct. So our nth expression is correct. That's for compound sequence. You may have fractions. You may have mixed numbers made of 3 sequences. Every whole number is a sequence. Every numerator is a sequence. Denominators is a sequence, and so on. It's not really difficult. And now let's say we have, I call this strange or weird sequence. A sequence that I would say that is very, very difficult to find the nth term of if it was given to you by itself in the question, and they won't do that. Instead, they may give you a set of sequences in the same question. And a sequence could be compared to those, and I've showed you this in I think the second class of this topic, but I'm going to show you that again. A sequence, let's say we have sequence A. The sequence is 1, 8, 27, 64, 125, and we have another sequence B, which is 4, negative 2, negative 8, negative 14, negative 20. And we have sequence C, which could be for example, 2, 4, 8, 16, 32. And then we have another sequence D. Very often we've seen such a question in the external exams, where we have a set of sequences, and then you'll have to find the nth term of each. Let's say D is, let's say 6, 2, 0, 2, 12. And now we want to find the nth term, and then find the 10th term also. Sorry, let me take this out here. Let me make it this way. N equals 1, 2, 3, 4, 5. We want also 10 when n equals 10. Okay, that's a sequence called ABC. And we want also to find the nth term. Okay, I hope you didn't get bored waiting for me to finish this up. I hope that you were helping me doing it actually, and I hope that you are having a piece of paper and a pen and you're doing this with me, and then trying to beat me up and go ahead of me and find the answers. Okay, let's find the answers here. Now A, sequence A, you could notice that these are the cube numbers. So the nth expression will be n cubed. And as they start from 1. The 10th term will be 10 cubed. 1000. Now for sequence B, why didn't I check for the first whether it is arithmetic then geometric? Because it is cubic, you could just see it. Here, differences, minus 6, minus 6, minus 6, minus 6. So we have arithmetic with difference of negative 6. So this is negative 6n. And then you go back, you add 6 to this here, you get 10. So this is negative 6n plus 10. We've learned how to do it. For the 10th term, negative 6 times 10 is negative 60 plus 10, that's negative 50. Why do we have the finding the 10th term before finding the nth term? Some students may find it difficult to find the nth term, so at least they can find the 10th term and get marks for this. By the way, such a question would be worth 10 marks together. So you could find the 10th without finding the nth by noticing that minus 6, and you do it to get to the 10th term. Here you notice cube numbers and you do it, and so on. Right here, differences are 2, 4, 8, so it's not arithmetic. Times 2, times 2, times 2, so that is geometric. The first term 2 times 2 to the power of n minus 1, and that is 2 to the power of n. As you would simplify, it would be better to simplify. These are just the powers of 2 themselves. 2 to the power of 1, 2 to the power of 2. Good to know these numbers. 2, 4, 8, 16 is just 2 to the power of n. 3, 9, 27, 81, those are 3 to the power of n. And now we have here, difference is 4, minus 2, plus 2, plus 10. Definitely not arithmetic. Times 1/3, times 0. It's not geometric. Differences between the differences. And that is minus 4. This is minus 2. This is plus 2. And this is plus 10. Differences here. Negative plus 2. Negative 2 to positive 2, you added 4. From 2 to 10, you added 8. So it's not a quadratic. 2. 4, it's not a cubic. So what type of a sequence is this? It's not arithmetic. It's not geometric, nor quadratic, nor cubic. It's not compound. It's not sequences put together. So what would it be? I called that weird sequence. By itself, you won't see it in the exams. But along with other sequences, yes, you expect this. So you start looking for how those terms were generated from these sequences. You may have 2 of these sequences added up together, subtracted, multiplied. So you would have to check. For example, I might check 1 plus 4, 5. This is not it. 1 times 4, 4. That's not it. 4 times 2 is 8. It's not it. 4 plus 2, 6. Which see the others. Negative 2 plus 4, 2. Negative 8 plus 8, 0. Negative 14 plus 16 is 2. So you notice that D is actually B plus C. It's actually made of 2 sequences, B plus C. So you take the nth term of B plus 10 plus 2 to the power of n. That would be the answer for it. It would be very difficult without comparing to the others. So that's the way you would deal with it. Remember that, please, not to lose 2 or 3 marks. And finally, we have sometimes been asked to find the sum of the terms of a sequence. It's just you finding the sum, you add them up. But they may ask you to find the sum of 50 terms of a sequence. So you have, in other words, to find those 50 terms and then add them up, which will take long. I have a help for you here for finding the sum of the terms of just arithmetic sequence. And most of the times, or actually what I have seen, is finding the sum of arithmetic sequences. An arithmetic sequence in general is one term, we call it A, let's say, then you add the common difference, then you add another D, then you add another D, So that's plus D, plus D, plus D, and so on. You notice that this formula that we've taken in the arithmetic sequence came from this formation of the terms of an arithmetic sequence. You just have A every time. So you would have A in every term. In the last term, in the nth term, you must have an A, which is the first term. And then you have plus 0D, plus 1D, plus 2D, plus 3D. We have a plus a number times D, but that number is 1 less than its location of this one. N equals 1, so the coefficient of D is 0. N equals 2, the coefficient of D is 1. N equals 3, the coefficient of D is 2. N equals N, so the coefficient of D is N minus 1. And that's how we came up with this formula that I gave you earlier. Now, the sum of any arithmetic sequence is number of terms, N is number of terms, times first plus last term. Let's take an example. Find the sum of, let's say, 10 plus 20 plus 30 plus 200. And instead of just finding 10 plus 20 plus 30 on the calculator, you could do it, but they may give you a very large number here, so that will take long time. You could just use this formula. So sum is equal to, as this is arithmetic, number of terms, determine number of terms carefully. You could find number of terms by inspection. This is just like 1, 2, 3, 4 up to 20, so it's a 20 numbers. You could do it this way. Most of the times they don't want you to do more than this, but N equals how much? You could do it like this. 200 equals A plus N minus 1 times D. So 200 equals A, which is 10, plus N minus 1 times the difference, which is 10. So that is 200 equals 10 plus 10N minus 10. So 10N equals 200, divide by 10, N equals 20. That is if you have the terms of an arithmetic sequence and you couldn't find the number of terms in that sequence, you would do it this way. I don't expect this very much in the exams where you have to do this. That is in A level. But the numbers should be usually easy. 10, 20, 30 plus up to 200, so that is 20 terms divided by 2 using this formula right here, times the first plus the last, and that's it. And that is 10 times 210. The answer is 2100. That's the sum of these terms. If you want another example, I'll give you another example. Find the sum of the first 20 multiples of 3. Multiples of 3. Let me take another number of 200 here. We're using the same number of terms. Let me just change that into the first, I would say, let's say 40. First, 40 multiples of 3. This requires a skill of knowing what are the multiples of 3. You should know. If you don't know, that's it. You will lose the question. 3. Multiples of 3, 3 times 2, plus 9, plus 12, plus, up to, we want 40 multiples, not 40 here. If this is 1 times 3, 2 times 3, the 40th term will be 40 times 3. That's one way, quick inspection. Or you could say this is an arithmetic. 3n is the nth expression. So 3 times n would give you any term. 3 times 40 is 120. So we need to find the sum of these values. Now how many values we have? 40. So this is equal to 40 divided by 2 times the first plus the last. And that's it. And that is 126 times the 20, 252, 2,520. That would be the sum of these values. Reasonable? Yes, we have 120 plus plus and so on. Let me make sure again. 123 right here. 123 times, sorry, it seems like it's not correct. You could use your calculator for this. We have 123 times 2, 200, 123. 26. Yes, this will be it. That will be the answer. That's the sum of these values. So that's in case if you had to add up. And if you forget this, just add up the terms. Just add them up manually. All right? And now we have something called recurrence relation. We've been seeing such questions in the external exams, especially in the most recent exams, where you have to understand something like this. Nothing to be memorized here. Recurrence relation is how the terms of a sequence are formed as you go from term to the other. You may have, this is in general, if you have u of n minus 2 to represent any term, the one that comes after will be something like this here, u of 3, u of 4. Before that you have u of 1, u of 2, sorry, and u of 5 and so on. So notice that as you go on, the sub value here keeps on increasing by 1. So if you increase 1 here, if you add on 1, you get n minus 1. Add 1, you get n plus 1, n plus 2. This sequence of terms can be used to understand what's called recurrence relation. This is recurrence relation. Wow. Recurrence relation. This is a recurrence relation. What does it say? It doesn't say that this term, this specific term is equal to such and such. It says any term, u of n plus 1 or u of n, is just any term in a sequence. So any term in a sequence that is described by this recurrence relation is equal to 2 times, if this is u of n plus 1, u of n will be the one just before it, because it's 1 less than it in the sub value, plus a 3. As if we were saying, description of this, each term equals 2 times the term before it, then plus 3. Understand this. Don't get afraid of these symbols and you don't like them very much if you just understand this. So they may ask you to find u of 2, u of 3, and u of 1 must be given, because if you would notice that every term depends on the one before. So if you want to find the first term, you can't, because you don't know what is before it. That's why if they give you a recurrence relation, they'll give you value of the first term, and sometimes maybe the value of the first 2 terms if the term we're looking for depends on 2 terms before it. So now to find u of 2 is equal to 2 times u of 1 plus 3, and that's equal to 2 times 4 plus 3, which is equal to 11. You want to find u of 3? It's equal to 2 times u of 2 plus 3. So to find u of 3, you must find u of 2 first. Even if they were asking for u of 3 only, you'll have to find u of 2 first, and then u of 3 depends on it, as you see here. 2 times 11 plus 3, which is 22 plus 3, 25. 5, and so on. So you could find this sequence if they would ask you to find, for example, a next term or a 10th term or an nth term. This sequence is actually 4, 11, then 25. Then you may find u of 4 in case if they would ask you for something else based on this here. I want to give you just one more example on this here. As I said, if sometimes the term given may depend on 2 terms before it. Let's say we have this recurrence relation. Now this recurrence relation should be understood this way. I don't want you to read as u of n plus 2, makes no sense. But if you just read this is just any term in this sequence equals 3 times, this is the term before this one, just a term before it, minus 2 times the term before that. So we have to be given 2 terms, the first and the second, and then you may have to find the third, the fourth, and so on. So u over 3, for example, u over 3 is equal to, according to this rule, n is replaced, n plus 2 is replaced by 3, so n is replaced by 1. Replace every n by 1. 1 plus 1 is 2, so 3 of u of 2 minus 2 times u of 1. And we know u2 and u1. So u3, the third term, is equal to 3 times 5 minus 2 times 2. So u3 is equal to 15 minus 4, which is 11. You may see something like this in the exams. I hope that you have understood sequences in general from this topic, because we will move on to another topic later. We will take geometry, as we have finished algebra, we have finished number, we have finished algebra along with sequences. So next time we will start geometry, and I hope that you have understood this. I have one example for you here. Let's do it together. We have sequence A, B, C, D, and E. We are looking for the 6th term and the nth term. Now, you may find the 6th term of each sequence before you find the nth term. You could do it this way if you can. If not, you just find the nth term of each sequence and then substitute 6 for n to find the 6th term, and that was worth 12 marks. This is past paper question. So let's find out. This is 11, then 9, then 7, so minus 2, 5 terms. The 6 terms, minus 2 is 1. Easy to find. 1, 4, 9, 16. I hope you're familiar with this now. Square numbers. 2, 6, 12. 2 times 3, it's not working. Plus 4, plus, it's not working. We probably have a quadratic. You should check now, because it's not arithmetic and it's not geometric. So this must be 4 right here. 6, 8. If the differences have a common difference, it's clear here. So we have 2. Same difference. So that's n squared. Sorry, let me write it here. N squared. So it's related to the square numbers. So you may notice that instead of doing the other ways we have found it, you could still use them, but it should be usually easy. It's related to the square numbers, and I've seen them here. So I notice that this is, we just add 1, we add 2, we add 3, we add 4 to the n squared. Those 1, 2, 3 added are just n. So this is n squared plus n. Or you just do it anyway of the ways you've learned you like. So this will be 6 squared, 36 plus 6, which will be 42. Okay. For sequence D, we have 3, 9, 27, 81, 243. They look like the cube numbers, by the way, I think. But probably I would just follow the procedure for checking what type of sequence is this. Add 6, it's not 6, so it's not arithmetic. Find the differences or first find, do we have multiplication of the same number? Yes, it is. So this is times the 3, times the 3, times the 3, and so on. So this is geometric here. So you could just continue on times the 3, times the 3. You could find this value here, 729, is just by finding times the 3 right here. You get a mark for that at least if you don't know how to find the nth expression, and I hope you can, because it's really easy. It is geometric, so it is AR to the power of n minus 1. A is the first term. R is also 3 to the power of n minus 1. You could simplify. You could leave as it is. Laws of indices, the powers is 1 and n minus 1. Add them up, you get 1. And these are the powers of 3. Powers of 3. You could recognize them when you see them. Now let's go on to sequence E. Differences, plus 2, plus 12, it's not arithmetic. Times the 3, times 5, it's not geometric. So I'm going to have to check. The differences here, 12, what's that, 12? 35, 36, 46, 61 to 213, that is 113, 112, 152, I believe. The numbers, if you are familiar with sequences, if you have a practice, you would stop even finding differences here, because you should expect one of the sequences in a set of sequences in a question to be related to the other sequences. Differences are really different from each other. If you just continue on finding second row or third row of differences, that will take you time and you'll be wasting time. So instead of that, check whether this sequence is formed from those other sequences. So you spend 1 minute or more, because that would be worth at least 2 marks. You could, for example, say this is maybe 11 minus 1, it's not 10. So there is difference, 11 plus 1, 1 plus 2. You just check like that. You have to have a good vision here. 3 minus 2, 9 minus 6 equals 3, 27 minus 12. So it is formed from taking every term of D and subtract C. So it is D minus C. The nth term of D minus the nth term of C. Believe it or not, this is not correct. It's not correct. You have to be careful. It's minus n squared plus n. So you put this in brackets. If you don't want to put brackets, this must be minus. So you have to be very careful. Now, to tell you something, you would discover your mistake if you have checked whether this is correct. So check that for example, the second term. If n equals 2, check. N equals 2. 3 squared minus, let me not put the brackets, as if I have forgotten to put the brackets. 2 squared, n is 2, plus 2. 9 minus 4 is 5, plus 2 is 7. We have a 3, not 7. So you may fix this up. Don't panic. Take your time and try to fix it up. If it was like this now, 2 squared plus 2 is 4, plus 2 that is 6. 3 squared is 9. 9 minus 6 is 3. So this is correct. So please check every nth term you get before you move on. And I hope that you have understood sequences in general from this topic. Any questions about sequences, please revise this topic, topic 4. Classes 1 to 6, you'll find your answer for any question you have about sequences, hopefully. And here I have just one question for you. Read the question, get the answer correct, pick it from the answers you have, and I hope you get it correct. Thank you for watching, and hope to see you in another video. Thank you.